Welcome students. In today's video, we're going to take a look at identifying independent and dependent variables and how we can write equations based on some real world situations. Oh my, I'm excited. All right, before we get started though, I've been having some thoughts on life here. I've been thinking that relationships are a lot like algebra in that you look at your ex and you wonder why. Huh? Nothing?
Bruh.
All right. Anyway, before we can jump into the examples here, we first got to understand what are independent and dependent variables. So when we talk about independent variables, those are our x values, and they're considered the cause or the input variables. Those are the ones that are going to affect the change in the y value or the dependent variable. Dependent variables are your y values, and they're considered the effect or the output variables. So if we think some are easy to identify what the cause and what the effect is, you'll often see these written though using input-output tables where we're going to see there's clearly one that's making the other one happen, right? The independent variable is the input or the cause, and the dependent variable is your output or your effect. All right, let's take a look at our example here. So Joey, he loves beans, but the problem is they give him gas. He found that each ounce of beans he eats, he is gassy for about 3 hours. I don't really want to be around him when he's running that experiment. Okay, it says Joey wants to create an equation that will give him the total number of hours he will be gassy, H, given the number of ounces of beans he eats, B. Determine the independent and dependent variables and create a table to show the number of hours he will be gassy after eating 1 to 5 ounces of beans. Finally, write an equation to represent the number of hours he'll be gassy for any amount of beans he eats. All right. I can't promise I'm going to stop with the fart noises because I don't think I'm going to. So anyway, our first thing here is we got to figure out what our cause is, what our effect is, right? What is our independent variable? What is our dependent variable? So when we look at our question here, we're given two sets of information. Make sure I'm on black here, sorry. We're given two variables here, right? We're shown that the hours he's going to be gassy, that's H, and we see the ounces of beans he eats, that's B. And we have to figure out which ones of those is the independent variable, the cause or the input, and which one is the dependent variable, which is the y or the effect or the output. All right, in this situation, we can think about like, all right, the thing that makes him gassy is the beans, right? How many ounces of beans he eats. So that's going to be our independent variable. That's the cause here. So our independent variable will be B, which is the ounces of beans that he eats. All right, and our dependent variable is going to be H. That's the effect, right? How long is he gassy? So the hours that he's gassy. Okay. Before we jump into our equation, let's take this information, let's put it on our table. Let's create our table first, right? Let's create our table of data. So our independent variable, our x value, is typically going to go on the left in standard form. So this one is going to be your x or your independent. I'm just going to shorten that as IND. And on the right, this is going to be your y or your dependent variable. Just going to shorten that to DEP. So our independent variable we said was ounces of beans. And then I will make sure I label that with the variable, which is B. And then my dependent variable was the hours he's gassy. Hold on. Hours he's gassy. That's better. which is RH. Okay. When we think about our ounces of beans that he could eat, it tells us to create a table to show the hours he'll be gassy after eating 1 to 5 ounces of beans. So we're just going to straight number these 1 through 5. So 1, 2, 3, 4, 5. All right. And he found through experimentation, through collecting data, which I don't want to be around while he's running those data simulations, right? That he'll be gassy for about 3 hours per ounce of beans that he eats. So that means 1 ounce would be 3 hours, right? 2 ounces means it's going to be 6 hours. 3 ounces, 9 hours. Right? We see it's just going up by 3. 4 ounces, 12 hours. 5 ounces, 15 hours. All right. To write our equation, we have to ask ourselves, what is the relationship between the independent variable and the dependent variable? Meaning, how am I getting from the X column, which in this case is ounces of beans, to the Y column, which is hours that he's gassy? What am I doing to that number to get over to the other side, right? And when we think about that, and I'm going to switch colors here, what am I doing to 1 to get to 3 that will also get me from 2 to 6 and 3 to 9 and 4 to 12 and 5 to 15, right? And the answer is that I'm multiplying by 3, because I see that for every ounce of beans he eats, he's gassy for 3 hours. So if I just take 1 times 3, I get 3, right? If he eats 2 ounces of beans, 3 hours for each ounce, 2 times 3 gives me 6, right? So now that I see that relationship is there, it's staying constant, right? I'm just multiplying by 3 for each ounce of beans that he eats. Well, really, this is just the B column, right? So this is really just B, and we're multiplying that by 3, so B times 3, and what does that give me? Well, it gives me my H, my hours that he's gassy, right? So if I'm trying to write an equation for this, all I really need to do is look at my table that I made and go, what is happening in this table? What can I do to X to get over to Y? So when I write this as an equation, it's really just going to be B times 3 equals H, right? But when I write this, I want to write it in standard form. So standard form in algebra, multiplication between a number and a variable is implied. So really, all I need to say is 3b equals h, right? Because that 3 is directly next to the b, it implies multiplication. It is the coefficient of b. Or you could write it as h equals 3b. And both of those are correct ways that we can write that. They're the same equation, just flipped around. All right, and now I know what you're wondering. You're like, hey, well, why do I need this equation anyway? What does the equation do? Well, now that I have an equation, I can answer some real-world situations, right? I can apply this to information. I can answer questions that I might want to ask down the road. For example, I could ask questions like, hey, I saw Joey eat a bean burrito with at least an ounce of beans on it for lunch 2 hours ago. Is it safe to get an elevator with him, or should I wait for the next one? And I would probably wait for the next one to be safe, right? Or maybe for Joey's sake, he says, hey, I have a dentist appointment in 8 hours. How many ounces of beans can I safely eat to avoid an embarrassing interaction with a cute dental hygienist I have a crush on? You know what I mean? Those things are important. You got to make sure you're setting yourself up. So by writing this equation, Joey can now apply this and answer questions that he might have in the real world. All right. Thank you very much for watching. I appreciate your focus here. As always, make sure you're clicking that subscribe button at the bottom, and I hope you have an excellent day.
That was easy.